Now it's time to practice. We'll try graphing these parabolas and see how each transformation affects their shape. As you practice, notice the role of each value and how it changes the graph.
Now for example 3, we're going to go a little bit harder and add a coefficient to the x squared, which makes this non-monic. Alright, so we still follow the same steps. First step is to find the y-intercept or let x equal 0. Or you can just look at the c value. So our y-intercept would be 9. Now for the second step, let's find our x-intercepts. Now this is where it gets a bit more harder. So you can never factorize if there's a negative outside, so we can throw the negative out by dividing everything by -1. So we would change the signs. And now we would factorize this. You can either use PSF, but I use cross method, so you'd use 2x and x, since these two multiply to 2x squared. And now for these two numbers, you would put 2 factors of 9 that multiply with these ones to give you +3. And that would be -3 and 3. As this is -6x and 3x. Nope, that doesn't work. Let's try this and this. 6x minus 3x. So this would be 6x and this would be minus 3x. That gives us 3x here. So this works. But how to factorize this, you would take these brackets. And it would be 2x minus 3x plus 3 equals 0. Now we're done. We can just write x equals 3 on 2 from here. And x equals -3 from here. We've got our x-intercepts. And now we've got our y-intercepts. And all we need is our axis of symmetry, which is just x equals -b on 2a. In this case, our -b would be -3, and our a would be -2, so it would be 2, -2, which gives us 3 and -4. So this is our axis of symmetry. Now, when you substitute your x coordinate for your vertex, you would get approximately 10.125. So we've got our 3 things: our vertex, our x coordinates, our x-intercepts, and our y-intercepts. So now we can sketch the graph. Y-intercept at 9, vertex at -3 on 4 and 10, so be up here. And our x-intercepts are 3 on 2, so around here. And -3 on 2, +3 on 2. And -3. So we'd sketch this. And then this would be our parabola. Now for this example, I'll be showing you something called the quadratic formula, which you use when there's like absolutely no way you can factorize this. So the quadratic formula is x equals -b plus or minus √b squared minus 4ac divided by 2a. That's our quadratic formula. So y-intercept is easy. It's just this 0, 0. Look at this value. So basically y equals 20. That's a y-intercept. Now for the x-intercept, there's no way you can factorize this. So you would use this. This would give you your x-intercept, the quadratic formula. So you would substitute your b, a, and c values into this. -1, 3, and 20. So -b plus or minus 9 minus 4, -1, 20, divided by -2. So you keep on going. We cancel these negatives out, so it would just be 3 plus or minus root. Multiply this, be 20 times -1, which is -20 times +4. 80 plus 9, so 89. Divide by 2. So these two, 3 plus root 89 divided by 2 and 3 minus root 89 divided by 2 are your x-intercepts. These two are your x-intercepts. So when you put this in the calculator, you get is approximately 3.21 and 6.21. So these two would be our x-intercepts. Now for the vertex, this same thing. X equals -b on 2a, which equals -3 on -2, which equals 3 on 2. And when you sub in your y value, you would get 22.25. So this will be our vertex. Now we can sketch the graph. Vertex at all the way up here, 22.5 and 3 on 2. Remember, this is negative, so it'll be concave down. It'll be in this shape here, right? When you got our intercept is -3.21, 6.21, and we just sketch this. Y-intercept is 20, so about here. You sketch this. This will be 20. This will be 3 on 2, 22.25. And this will be 6.21 and -3.21. And this would be your parabola.
With this lesson, now you can sketch parabolas, see how each transformation affects the shape, and see how these values allow us to transform the shape and position of the parabola. Thanks for watching, and I'll see you guys next time.